Question 19. Graph the following function and state their domain and range. Okay, I have only selected one problem here. There were two functions, and state its domain and range. Okay. Now, the function is y equals to minus 2 square root of minus 1 over 3x plus 1 plus 2. Now, if you have a function like this, first thing which I think you should notice is that the coefficient of x is not 1. So if coefficient of x is not 1, you have to factor out this term, right? This is your term which decides horizontal stretch or compression or reflection, correct? This has to be factored out before you write your transformations, right? So that's the first thing you have to do. Second, you should list all the transformations beforehand and try to make a rough sketch, okay? And third, you should find out the transform points, right? There are two approaches to graph this kind of a function. One is we can do step by step. That means taking one transformation at a time in a particular order. Okay. So what I will do here is teach you the method of doing it and then leave the sketch to you. Okay. So let's adopt first thing first, and that is to write the equation in the right way. The right way means the way which will help us to really use for transformation. Okay. So let me do that part first. So we have y equals to minus 2 square root of this. So that should be equal to, so minus 2 square root of, factor out minus 1 over 3. So if I factor 1 over 3, then I'm left with x, and plus divided by minus is minus, and 1 divided by 1 over 3 will give us 3, right? And that is the square root part, and then plus 2 outside. So that becomes our equation. Now, if you don't do this, then you'll get your horizontal translation wrong. Do you understand? And I have seen this mistake in many test papers. So that is a very, very important step. Okay. Now the second is, let's write down the transform points. Now, in this kind of an equation, let's say the original points are xy. Then, what are the transform points? As far as x points are concerned, they are the points which are influenced by the function itself, right? Now here, x gets multiplied by minus 3, correct? And then you add 3. So, original x points will change or get transformed to a position. New position points or the image points will have the coordinates as minus 3x plus 3. So these are your x points. And the y points will be minus 2y. Let me write here, minus 2y plus 2. So these are our transform points, right? We call them image points. And these are original points. Okay? So you can always take some original points which are our key points and transform them to the new location, connect them, get your answer. Okay. So let's take some key points. For a square root function, the key points are, it starts with 0, right? Its domain is in the first quadrant. Its domain is greater than or equal to 0. So at 0, for square root function, 0, 0. The other key point is at 1, square root of 1 is 1. And then you know square root of 4 is 2. And square root of 9 is 3, correct? So these are your key points. Now when you transform them, you can apply this formula and get your transform points. So if I do minus 3 times 0, it remains 0, and we get 3, correct? So the 0, 0 point kind of vertex for your square root, the corner point kind of changes to 3, 2, right? If I plug in 1 here, minus 3 times 1 is minus 3. Minus 3 plus 3 is 0. So you get 0. And 1 here, minus 2 plus 2 is also 0. You get 0, 0. And if I put 4, 4 minus 3 is minus 12. Minus 12 plus 3 is minus 9. And 2 will give me minus 4 plus 2 as minus 2, correct? Now if I plug in 9, minus 27 plus 3 gives me minus 24, and 3 times 2 is minus 6, plus 2 gives me minus 4, correct? So these are my new points. You can always plot these points on the graph. 3, 2, so you'll go to 1, 2, 3, 1, 2, you get this point, right? And then you come to 0, 0, that's your point, 0, 0. Then minus 9, minus 2, so you say 1, 2, 3, 4, 5, 6, 7, 8, 9, oh sorry, and minus 2. So that's your point. And minus 24 you can't plot, so these are enough, right? So you can always join these and get your final answer, correct? Now, so let me just join them for you. And don't forget to put an arrow at the end. So that becomes your final graph. But let me explain you that this is what you could get straight about the steps involved if we do it one by one, okay? So let's make it here itself. So I'll make a small sketch to show you in steps how does it get transformed. So first is a square root function, right? So we have square root function like this, right? Now we are going to reflect this graph, and if you reflect it, you can do the first two operations at the same time, that is reflect and then stretch, right? So this function becomes kind of like this, right? This is like minus 2 square root x, and this one is square root x for us. Perfect. Now then we are moving from left to right. Note, if you move from left to right, you will perform the orders in the right order, the transformations, right? You'll perform the transformations in the right order always. The second option for you is, of course, you can do horizontal stretch, compression, reflection first, and then do vertical stretch, compression, and reflection. And at the end, you have to do the translations. Okay. Now, here we are supposed to stretch it by a factor of 3, right? So, if you stretch it by a factor of 3, then every point gets stretched out by a factor of 3, right? And then you have to reflect it also. So what really happens is that, okay, let's do it in steps. So first we can reflect it, right? So this graph here becomes like this. And this, let me call this as minus 2 square root of, I'm only using minus at this time, so minus x. Is that okay? So that we have taken reflection on y-axis at this point. And now let's try to stretch it, correct? So if you stretch it, then every point has to be stretched by a factor of 3. Factor means multiply by 3. So if this is 0, 0 remains at 0, and 1, this is minus 1, right? So critical point for us was this minus 1, for example, right? This gets multiplied by 3, and we get this point to minus 3. So this was 1, 2, 3, kind of. Do you understand? So this gets stretched 3 times. So this comes here. Similarly, this point will go somewhere there. Do you understand? So when you do stretching, it becomes like this kind of. And so now we get here minus 2 square root of minus 1 over 3 x. Everything square root. Do you see that? So this is like the stretched part, correct? And the last part is, of course, to translate and draw your final graph, correct? So when you translate it, you have translated 3 units to the right and 2 units up. Do you see that? 3 units to right, 2 units up, correct? So it comes to 1, 2, 3 units right and 2 units up, right? Somewhere there, right? And then it gets kind of messy. This one, and this is your f of x, as you see here, correct? So here I have shown you the sketching of the function in steps. So that is the second method, right? Now, there could be many questions related to this problem. One, of course, is that write the sequence of transformations being performed here, correct? Which will be, as I've shown you here, correct? So let me put those sequence here in short. So first is reflect on x-axis. Second is vertical stretch by a factor of 2. So I say vertical stretch by factor of 2. Important word is factor. If you don't write factor, then we are not sure whether you want to add or you want to multiply by 2. Do you understand? So vertical stretch by factor of 2 is important, right? And the negative inside relates to reflection on y-axis, correct? And then 1 over 3 is horizontal stretch. So horizontal stretch by factor of 3, correct? And then last, we can combine both translations, right? Translate 3 units to right and 2 units up. So these are a set of transformations, correct? So that actually completes this problem. Now last is domain and range, correct? Now from here also you can see what domain and range is. So you can write down here domain is x belongs to real numbers, where x is less than equal to 3, correct? And range is y belongs to real numbers, where y is less than equal to 2, correct? That's domain and range for the function, correct? Have a good look at this, and I hope you understand all the transformations which we have done in domain and range of the function, and 2 different methods which I taught you here. Sometimes it is specified, follow a method, you have to follow that method. If not specified, you can take the one of your choice. Okay, thank you.